Hello, Professor Sanchez, or whoever else is watching this on YouTube. This is my ECE 1240 Exam 4 tutorial, replacing problem 2. And this is my circuit. So first of all, for this problem, I need to determine the current flowing through the inductor as a function of time. So we can see there's a switch that at t equals 0 is open. There's a 15 amp current source, 24 ohm in parallel with a 24 ohm resistor, a 12 ohm, 8 ohm, and 5 ohm resistor, and a 2 Henry inductor. First off, I labeled and solved for the current in each of the branches at t less than or equal, or at t less than 0, sorry. We can see that these currents progressively get larger. This current is 2.5 amps, this current is 5 amps, and this current is 7.5 amps. This makes sense because these currents are adding until they get to the last branch. So we know that that's correct. Then we can redraw the circuit at t is greater than 0, which would just look something like this, where the current source is no longer a part of the circuit. And since we have these three resistors here, we can find the equivalent resistance, which I did. You can take the 12 ohm and the 8 ohm resistor in parallel, which gives you a 5 ohm resistor in parallel with a 20 ohm resistor. And then you can take those two in parallel, which will give you a resistance value of just 4 ohms, which is our equivalent resistance value, in parallel with our 2 Henry inductor. So we know that our time constant tau is the inductance, or L, over the resistance, which is R. So that would be 2 Henrys over 4 ohms, which is 0.5 seconds. So we can start to write our equation. So IL of t would be equal to I initial times e to the negative t divided by tau. So our I initial in this case, in that branch, would be 5 amps in the branch with the 12 ohm resistor. So we know that that current is 5 amps. So that would be 5 amps times e to the negative t divided by 0.5 seconds. And we can rearrange that. So we have IL of t equal to 5 amps times e to the negative 2t. And this would be the current through the inductor as a function of time. Thank you.